This is Michael Fox, and this is the Prospector News Podcast. And joining me today are the president of the Uranium Producers of America, Scott Melbye. Welcome again, Scott.
Hi, Michael. It's always a pleasure to be on your show.
Yes, well, what I wanted to talk to you about today is I want to start having a conversation about the small modular reactors. There's been some good news and bad news in the market with them. On a good news statement, the government of Canada has awarded SNC Lavalin of Montreal, the engineering contractor, to start producing the first of these small modular reactors in Canada. But a bad news was that the one that was slated for commissioning in Wyoming's been delayed a couple of years due to fuel problems. So I wanted to have a conversation with someone in the know like yourself as to what exactly is a small modular reactor and how does it differ from the nuclear reactors that we're currently familiar with?
Yeah, no, that's a great starting point, and I will say just more generally that this emergence of the small modular reactors or advanced reactors is probably one of the most exciting developments, not just in nuclear energy space, but in terms of delivering carbon-free, reliable, affordable power going forward, especially as the world makes it harder on carbon-emitting sources of electricity going forward. So in terms of definitions, small modular reactors or SMRs, these are the smaller, could be anywhere from 50, 100, 200 megawatt reactors that are built in factory, shipped on site, as opposed to traditional reactors, which are 1,000 to 1,600 megawatts, big, massive construction projects. I've had it described to me, and I like the analogy, is that a large 1,600 megawatt reactor is like building a major airport in terms of an infrastructure project. Building SMRs are more akin to building airplanes. And that has, huge impact. Obviously, the economies of scale, building these in a factory, shipping them on site, obviously a longer lead time to construction, lower capital cost, scalable operations. And it really, there's so many advantages to these smaller sizes, and it's not surprising we're seeing countries all around the world kind of move in this direction. Now, other sort of definitions, you also have micro reactors, which are in the 1, 2 to 3 megawatt category. These could be, the size of a power system that would fit in a shipping container. That could be a source of power for a military base or a remote mining operation or remote community. And then advanced reactors are kind of another subset of small modular reactors. They tend to be, could be anywhere from 100 to 300, 400 megawatts, but are instead of just variations of existing reactors just made smaller, they're sort of next generation advanced designs that might be, spherical fuel assemblies or molten salt reactors. Basically, either taking ideas that really didn't get traction the last, as nuclear power emerged in the 70s and 80s, we kind of very quickly gravitated to light water reactors, both PWRs and BWRs, and companies like GE and Westinghouse really dominated the scene. Didn't mean there weren't other reactor designs. Obviously, CANDU reactors in Canada had to compete in that world, and they did manage to get market share in certain markets like Argentina, Romania, and Canada. But some of these advanced reactor designs are sort of previous designs that didn't get a full shake last go around, but are now improved through better materials, fuel designs, control systems. So SMRs and advanced reactors kind of run that whole gamut, but it's really presents an interesting dynamic for nuclear energy to grow right now.
Yeah, I kind of pictured it as kind of like a Lego set, that these reactors, depending on the size of the power grid that you needed them to fuel, was kind of like adding blocks on a Lego set. Is that a fair analogy?
That is a fair analogy. I mean, they are very scalable. I can think of a design like Nuscale, where you add 100 megawatt units at a time, and you might start with 6, but you could allow for growth to 12. And the applications are so enormous. I serve as an advisor to the nuclear engineering department at the Colorado School of Mines, and as I talk to young people who have finished their undergraduate and wondering where to go in terms of their advanced degrees, I encourage them that if you want a career that's truly, can change the world in terms of delivery of clean energy and very exciting from an engineering perspective, I encourage them to get into the SMRs, because the applications are limitless. I mean, obviously we've kind of thought of these as off scale or off grid energy sources that could power northern communities in the Yukon, Northwest Territories, and Ontario, Quebec, island nations that, Hawaii in 2023 is still generating electricity from diesel oil with dirty plants on the coastline there. So those are obvious, but I think we're now beginning to see too that on-grid applications in smaller loads like Wyoming, where plopping a 1,600 megawatt reactor into that grid would probably overwhelm it given the load requirements there. But a smaller reactor is a better fit, and also the ability of SMRs to coexist with renewables, because the fact is we have put so much renewable wind and solar on grids that it's a nightmare to manage as power planners when a power source only runs 30% of the time and it's really dependent on the sun and the wind. You need something that ramps up quite quickly and can ramp down quite quickly, and SMRs fit that measure. Now, other applications: hydrogen production, desalination of water, powering data centers, or even crypto mining in a clean, carbon-free way, just open up enormous markets. Maritime companies like CorePower are developing small reactors for the commercial shipping fleets around the world that are under great pressure to lower their carbon footprint. And a big, freighter or tanker, it'd be pretty hard to run that on a windmill or sails. You need something that can power that, just like we use small modular reactors in aircraft carriers and submarines. We have 104 of them that have been operating safely and efficiently since the 50s without incident, without injury or radiological accident. Sailors in the Navy have been sleeping on the other side of a steel wall from a reactor in submarines under the ocean for 4 or 5 months at a time without any impact on them. So it's pretty clear we can build these on land and really take advantage of that small scalable nature.
Yeah, I was about to say, hasn't the military been using this technology to power their ships for the last several decades? And you've addressed that. So let's you go to Wyoming for a second. You said that if you'd put in a larger reactor there, it would overwhelm the power grid. So let's say we put in one of these modular reactors today, and 25 years from now, we need to increase the amount of power for the state of Wyoming. Is it we have to scrap the original module, or do we just simply add another module to the reactor?
Well, I think some designs are designed to be scalable and modular, where you add units as you get financing, as your energy needs increase, you can add units in that fashion. I think in Wyoming, the way they're looking at it is the Pacific Corp, which is a Warren Buffett company that provides power throughout the Mountain West. We're faced with the shutdown of 4 coal-fired power stations in Wyoming, which is amazing. If coal-fired plants, can be slated for closure in Wyoming, they can be closed down anywhere. But the reality is they made the decision to phase these out by the end of the decade. And a decision was made early on to look at small modular reactors. And they actually put the competition for who gets this reactor of those 4 coal-fired power stations and the communities that support those. There's enormous interest and competition by those communities to try to get the plant sited in their community. Why? Because the existing grid connections are all there. And when you demolish the coal-fired power plant, you build the SMR on that site and you plug right into the grid interconnections. The jobs are transferable. It's disingenuous to tell a coal worker in Wyoming that, well, you can repurpose yourself and make solar panels. I mean, those are made by slave labor in China. So it's disingenuous to tell them that. But if you tell them we're decommissioning this coal plant and you're going to build this small modular reactor, there'll be operator jobs, there'll be fuel jobs in terms of the uranium mining in Wyoming as well. That is an ideal transition to cleaner energy that doesn't upset the local economies in the way that other type initiatives could. So the first reactor in Wyoming is going into Kemmerer in the southwestern corner of the state, but there are 3 other sites there in Gillette and Glenrock and elsewhere that if this is a success, I think it will be replicated at those other sites. And that's an important point. So right now, we're at a stage where SMR reactors are really, they've gone from the concept car. A few years back, you would hear about these and go, that's great. Where can I buy one? And it's like, well, no, that's just a concept car at the auto show. You can't actually buy one. Well, these have gone from that sort of conceptual stage to actual deployment and construction, where we now have the first of a kind projects being built for several reactor manufacturers. And these are companies like TerraPower, which is the Wyoming project, which is owned by Bill Gates. You have X Energy, which is going into Washington State and Eastern Washington State. You have Nuscale, which is going into Idaho at the Idaho National Labs. And incidentally, they're now a publicly traded company under the ticker symbol SMR, which is interesting. And then in Canada, you have perhaps the most advanced project is GE Hitachi going into the Darlington site in Ontario, and a lot of focus and interest in the UK with Rolls-Royce that had manufactured naval reactors for the British Navy, now manufacturing small modular reactors, as much as 16 that could be deployed throughout the UK and Wales and England and potentially Scotland. So we're really at that stage now, but it is critically important that these first of a kind units are built on schedule, on budget, and demonstrate success. And if you talk to any of the CEOs of these reactor companies, they all say the first order is the toughest one. We have hundreds of orders for units, for the 3rd, 4th, and 5th projects. And so it's not surprising too that you have a heavy element of cost sharing with governments. The Department of Energy in the US through the ARDP project is funding 50-50 development of these first 3 one-of-a-kind projects in those 3 states. In Canada, you have a very strong support by the Canadian government. Same thing in the UK. But the idea is that these get built, demonstrated, and then I think the commercial orders that come in to follow will be exponential. And we, in terms of, I'm in the uranium business, if we look at the impact on uranium requirements that this provides between now and 2030, it will be significant, but it won't be substantial. It will be the uranium requirements from these first units that are all slated to be in production by 2030. But the impact in 2030 to 2040 is exponential. As hundreds of these are built, ordered, and dispatched around the world. And so it's a great story for uranium. We already are seeing significant 3 to 4% annual growth in uranium requirements based on some 68 reactors, big reactors that have come online around the world, and the 58 very large reactors that are under construction. Even if there were no SMRs, our nuclear growth story would be very robust and very positive. You layer on these SMRs on top of it, and it's very, for uranium producers, this is a very exciting development that, we already need to develop probably 8 to 10 additional mines around the world of varying sizes to meet the current demand from the large conventional reactors. We're going to need to set our sights even higher as these SMRs tend to, start to gain some traction.
Yeah, I find it really interesting, and even in solid blue states where the environment is king and nothing else matters, you see state governors starting to trip over each other to try and get access to these modular reactors to come into their state to replace their coal and their natural gas fired power plants.
It's critical, and it's a nuts and bolts issue. This isn't, energy policy isn't virtue signaling, like banning plastic bags or straws. It's delivering electricity to your region or state, which has a bearing on your economy, your standard of living, even health and safety of people that live there. So I think many governors, faced with the reality that the coal plants have a limited lifetime in this green energy world, whether we agree with that or not, that's where society's headed. I live in Colorado. I get more than half of my electricity from Powder River Basin coal in Wyoming. If we decommission those coal-fired power plants without good replacements, and I don't mean wind and solar that run 30% of the time, I'm going to have very expensive, unreliable electricity. And that's what governors in Montana and Alaska and all over the West, it's huge interest throughout the West, Minnesota and the Midwest, in the Southeast, you have discussions in Tennessee and elsewhere. I think they're really wanting to at least lay the groundwork where these SMRs can be put into the planning process as a source of energy that they transition to over time. Some states obviously are ahead of others, but it's very viable alternatives for power energy planners going forward, and also industries. You follow the mining industry as close as anybody, and the ESG pledges that companies like Newmont and Barrick and big mining companies have made to decarbonize their mining operations by serious reductions by 2035, and sometimes complete reductions of carbon at their mines by 2050. Well, it's pretty difficult to run a big underground or open pit mine on windmills or solar, especially depending on where those mines are located. And so we're hopeful that these SMRs and microreactors could present a pathway for mining companies, petrochemical companies, anyone who has big energy needs, not only electricity, but process heat, because these plants can also produce process heat that would be valuable in places like the oil sands of Alberta. And so look for a lot of these ventures. We've already begun to see it in Russia, where there's a gold mine in the far reaches there of Russia, where we've got a gold mine being powered by a floating reactor offshore of the mine. You've got KGHM in Poland, big copper producer and miner and refiner in Poland, looking to build a Nuscale reactor. Why? Because it's that carbon-free energy that they get to advertise their green copper, but it also allows them to run. You can't have big smelters or mines with intermittent power outages and unreliable electricity.
So with these modular reactors, is there less nuclear waste that comes from them than versus the old style reactors? I guess what I'm getting to is the environmental movement going to, continue down the road where they seem to be embracing nuclear? But is there eventually going to reach the point where you're going to start to hear that radiation versus carbon pushback?
Mm-hmm. Well, the fuel cycle is very different with each one of these reactors. One that's very interesting, if you want to Google it, is X Energy. The fuel assemblies are literally spherical balls with uranium inside a very heavy steel and graphite ball, which the balls are fed into the reactor, much like a gumball machine, where they create the heat to boil the water to make steam. Others are more, like I said, kind of small versions of bigger reactors, so it's just smaller fuel assemblies. So the uranium requirements are proportional to the megawatt outage, and as is the back end waste. So you still are going to need to deal with either reprocessing a fuel like is done in France, or permanent storage of waste, like we've proposed in the U.S., or have been just politically unable to get that forward. But it's not all the waste that's been produced by the nuclear energy industry, since the 50s would all fit on a football field 16 feet high. So we're not talking about an overwhelming amount of waste, but in terms of radiation and risk, these, it's hard to be safer than the current fleet of reactors, because it's the safest form of energy we've known over the last 60 years based on injuries or deaths. So it's got equivalent or even better safety record than wind and solar. But these small reactors are even safer. They have walk-away safe features in them that rely on physics and not a lot of human interaction in sort of accident scenarios. If you lost offsite power, many of these designs are designed to go into a safe cold shutdown, even without operators initiating that, just on natural physics and forces. So, and just the smaller footprint, in a big 1,600 megawatt reactor, you may have a 15-mile exclusion zone where you have to stay in touch with the businesses and homes in that region and warn them of any unusual events at the plant that they should be aware of. With a small modular reactor, that exclusion zone may actually be the fence line of the facility. So that has huge advantages in terms of siting and permitting and licensing. So again, that's safety is really a key advantage of these next generation designs. And I think take a country like Germany. I mean, obviously, the whole world now is reversing phase outs and extending life of plants and everything else. Germany's still heading down that shutdown, although they may keep the 3 units open a little longer given what's happening with Russia, Ukraine. But I think SMRs could even appeal to places like that, where they've said, okay, well, we're not interested in large reactors, but you might have the political and public acceptance of advanced reactor, advanced design, or small modular reactor, which could go into those sites of previous large reactors and continue to produce nuclear energy just in these smaller packages. So I think there is, you see it in Washington, we have enormous interest and support by Democrats as much as Republicans. You mentioned the Wyoming project. One of the Achilles heel there is that some of these advanced reactor designs, not all of them, but some of them run on a higher octane, a 20% enriched level fuel, as opposed to 5% of the standard fuel enrichments. We don't have the capabilities in the United States or Western Europe presently to make that type of fuel. The only one that does is Russia. And obviously, I lobbied very heavily that we shouldn't have, even before Ukraine, Russia, it was a bad idea to rely on them for this kind of fuel. Now it's just obviously imperative. So the project was delayed 2 years to allow efforts to get the HALEU fuel cycle up and running in the United States. And I just had the first kickoff meeting of the HALEU Coalition, which are the companies that are advising the US government and the DOE on how to get that program up and running, which will ultimately be an RFP for 25 metric tons of HALEU fuel. The US government really wants to kickstart this and make it happen faster, and so we don't impact any additional startup dates of these small modular reactors. And that the funding of that has really been forthcoming by both Democrats and Republicans in the House and Senate. So it's a reactor that everyone I think can love and embrace, and I think it really has enormous applications.
How long before that HALEU processing gets approved and be up and running?
Well, the first reactors, have really slated their startup dates for 28, 29, or 30 for some of these first-of-a-kind designs. So, we really need to have HALEU fuel here in the next couple of years produced and fabricated. And that may be difficult for the first fresh HALEU fuel being produced. But we've and I've personally been a big advocate of this approach and lobbied very heavily for it, again, even before Ukraine, Russia. But I've pushed that the US Department of Energy make available some blended down high enriched uranium that maybe it might have come from weapons programs, but is excess to strategic needs. Let's use that, blend it down to the high assay low enriched uranium levels, and make the first fuel assemblies from some of this blended down government inventory. And then, industry, domestic industry, and as I wear my hat as the Uranium Producers of America, the domestic miners, the conversion facility, and ultimately the enrichment companies, domestic enrichment companies will replace that borrowed material with U.S. origin material, which is unobligated for safeguards, can be used for defense purposes as well as commercial power production. So that's probably going to be, or will be, the source of the first fuel assemblies that keep those projects online. But very quickly, demand is outstripping supply. So we need to have an industry. And I think, it's great to have the government support, but I think also commercial industry will see the business model here if hundreds of these are going to be built and ordered around the world. And there are huge export opportunities. Central Europe, I mentioned Poland, but you've got Romania, Poland, Czech Republic, all these countries in Central Europe are having to move away from coal to be part of the EU, but they can't turn to Russia for natural gas. So nuclear is the answer for them. And some of these SMRs may be faster, more scalable options for them. And hence, it's probably one of the biggest growth markets.
How much quicker is it to have one of these SMRs come online versus the old style reactors?
Well, we definitely can't take the time that we took to build the last generation of big reactors here in the US. I think, more recent success, if you look at the big, 4 reactors built in the United Arab Emirates in Abu Dhabi, 4 large 1,500 megawatt reactors were built really within 10 years from initial concept to this now finally the last units kind of nearing commercial operation. That's pretty good for the big reactors, but they should be built in 4 or 5 years, not 10 years. With SMRs, I think given that they're built in factory, you don't have on-site engineering issues. That these should be able to be deployed much like turbine generators, gas turbines that GE might make in the gas turbine world. So it should be 2-3 years to build these, not 5 or 10. First ones are going to be more challenging than the subsequent, but that's what we're going through right now.
Yeah, but that's typical with any new product that's there. The first ones are the hard ones to make. After you've done it once, and it becomes easier each subsequent one. How many of these HALEU processing facilities are we going to need in the next 10 years, and how quickly can one of those be brought online?
Yeah, so the U.S. government, DOE in the meetings today, indicated that they would like to see diversity of supply and at least 2 domestic HALEU production centers emerge from this activity. But there's no reason why it can't be more. I think the commercial drivers, once this really takes off, you'll have more than that. But the idea is to get at least 2 up and running. It's a good question. How quickly to build these facilities? I mean, it's kind of been the chicken or the egg, and it's probably the reason that DOE has gotten involved is that, if you're going to spend hundreds of millions of dollars or $1 billion to build this plant, you want to be sure that there's a market, and the market isn't going to evolve for these small modular reactors until they have fuel. So it's a catch-22. And that's where DOE is trying to come in and bridge that gap and place the orders for the first quantities that get these up and running in 5 years rather than longer than that. So I think that's kind of the order, the RFP that's going out by the Department of Energy is probably going to hit the market for 25 metric tons of this HALEU material, maybe later this month, and they intend to make awards by the end of this year. So that's pretty fast, and it has to be. I mean, there's a sense of urgency. We just can't rely on Russia for our energy needs. And as we're exporting these projects, we have great U.S. companies with U.S. technology. Our ability to export these and really regain nuclear leadership around the world. In these countries in Central Europe, America can be the leading company there building these projects, but we can't build them and then say turn to Russia for the fuel. We've got to be able to build them, provide the technology, and provide the fuel that's sourced in the West.
Yeah, well, it sounds like everything's coming to a head, that it should be some bluer skies come 2030, but there's still challenges between now and then, I'm hearing.
Yeah, I mean, it's all about execution now. I mean, the desire's there, the market's there, the government support is there, and now it's up to industry to execute, and it's critically important. In the UK, there's complaints that the government's not moving fast enough because the UK has been pretty much over 40% reliant on nuclear power for its needs, electricity needs back to the 60s and 70s. A lot of those old reactors are now nearing end of life. And so for them, it's replacing older nuclear reactors with newer big reactors like that at Hinkley or Sizewell. And these small modular, up to 16 of these small modular reactors that Rolls-Royce can build, but they're still kind of getting bogged down at the in the parliament and funding and how to I think we're pretty much in many jurisdictions where we can't wait for the energy systems to collapse and then go into crisis mode. We've got to get out ahead of them and make a smooth energy transition.
How critical are we at this moment from that equation going from collapse to moving forward? Are we more likely to collapse before these come online, or are we more likely to have these come online before we hit the critical stage of collapse?
Well, I'm always an optimist, and I'm hoping we can head that off. But you're beginning to see the real implications. I mean, if you want to look at failed green energy policy. And I don't mean green, I mean, it's okay to have an objective of cleaner, greener energy. That's not the problem. It's just you've got to pursue math and science over just ideology. And we've seen it in Germany, where they 15 years ago pledged to move away from coal-fired fossil fuels and phase out nuclear power and go all wind and solar. Now, 15 years later, it's just resulted in power prices 60, 70, maybe 80% higher than neighboring nuclear France. They've made no dent in carbon emissions because they're restarting coal-fired power plants, and they're even extending the life, trying to extend the life of the remaining nuclear plants. But worst of all, it caused them to really be compromised in the Russian invasion of Ukraine and dealing with Russia in that matter, because Germany had just become so dependent on Russian gas. And so we don't have to wonder what failed green energy policy looks like. We can look at Germany. You've had bits and pieces of it in California, where we've had increasing blackouts. I think South Australia and Victoria, with too much renewables on a grid. I mean, again, I think there's been so much incentives given and subsidization, and states and countries have been building so much renewable capacity, and now they're beginning to realize, oh, wait a minute, without the natural gas or coal, they're beginning to face cost and reliability realities. And that's good. That's helping nuclear power, because we are reliable. We run 95% of the time, and we are hedged in terms of the fuel costs. And so it really is helping the narrative around nuclear. I hate to see certain regions around the world, or states or provinces, be impacted, but it is helping the nuclear narrative move forward.
Definitely. I think let's go with the glass half full conclusion to this discussion. If people want to learn more about these modular reactors, can they go to your website and find out more?
Yeah, what I would encourage them at the U.S. Department of Energy on their website, get on there and look at the Advanced Reactor Development Program, or ARDP. They will have a lot of information there. I would go to the World Nuclear Association and look at their information on small modular reactors. Or perhaps the most interesting place that you can go take a look is go to the websites of companies like X Energy, Nuscale, or TerraPower, or UltraSafe Nuclear, or Core Power, some of these small modular reactor companies, and see what they're doing. And I think you'll really get excited about it. It's again, has the ability to change the whole picture of energy policy going forward, really addresses a lot of the issues that society is facing today.
And if they want to learn more about the Uranium Producers of America, they would go where?
Yeah, you can, UPA has a limited website there, but I think if you, my company, Uranium Energy Corp, uraniumenergy.com, can provide you a lot of good information on the macro and where the markets are going and kind of uranium activities, but also the World Nuclear Association can give you kind of broader supply and demand outlook for uranium, which is perhaps never looked better. From my perspective, we are in a structural deficit for uranium as we go into this growth period, but that means there's going to be, a lot of new mines needed to be brought online in the United States and Canada and elsewhere, preferably in places that aren't controlled by Russia and China. So it's a very exciting time for the uranium industry, supporting the nuclear growth story in the world today.
Definitely, we're going to have lots of reasons to have you back on the podcast as we roll out the nuclear option for the new green economy. So thanks again for joining me today, Scott, and look forward to seeing you in our travels soon.
Great. Thank you, Michael. It's my pleasure.
The Prospector News podcast is for educational purposes only. The opinions expressed are those of the participants and are not to be taken as investment advice. Listeners need to do their own due diligence and seek advice of a licensed investment advisor.